Yeah, thank you, Liana. Good morning, everyone. A very warm welcome to my session, and thank you for listening in. Today, I'm going to talk about the cloud and what are our plans for the road ahead. And just to recap, I'm Kevin Ng. I'm the director of Codex. I manage two very exciting product platforms. One of them is the Government on Commercial Cloud, or what we call GCC, and the other one is Singapore Government Tech Stack, SG Tech Stack. And I want to share a little bit about the Codex platform again, which is made up of GCC and SG Tech Stack. I think it's a platform to deliver modern and reusable service for developers so that they can get right to work straight away instead of setting up all the application infrastructure as well as the scaffolding. And I think we like this Codex platform, right, to be such easy to use that people can get straight to work straight away. And as necessary, it should be transparent enough such that if they need any customization or configuration, they're able to tweak and fine-tune the performance. And this is how we like the Codex platform to be. And the base of this platform is what we call GCC. GCC provides standard compute services, storage services, network services, and security services to hold all our workloads and systems. It works very seamlessly with the SG Tech Stack base layer, which is comprised of engineering productivity tools to accelerate development. And of the base layer, there are a few components that I'll walk through very quickly. There's a toolchain component. It's all about the source code management, as well as a journey through the CI/CD pipeline. And then there's a runtime component. The runtime component is about runtime execution of our systems. And this is where you hear about new technology like Kubernetes, as well as serverless, that has been mentioned a couple of times today. And then we have the monitoring component. The monitoring component provides observability. It is a control center when the systems go into production. We are able to observe the performance and fine-tune the performance and react to incidents as and when needed. And seated on top of this base layer is what we have called the services layer. The services layer provides a set of reusable services that the developer can pick and choose to assemble their system. And I think this is enabled by what we call the communication component. It provides a set of reusable API services that product teams can develop their core component and wrap it up and serve it as APIs that different developers can use. But today, I'd like to spend a bit more time on GCC. And for us to understand GCC, we need to understand the difference between cloud and on-premise system. I think on top of the list, right, cloud is an expense line item. This is very different from on-prem data center resources, where these are capital investment. And one immediate implication to this is that there's no more long-term locked in to a particular contract, and these are not capital investment. And what this means is that we can think about moving systems onto the cloud much more easily. Much as we hate to think that we need to move workloads from one cloud provider to another, but if you think about it, it's definitely much easier to move workloads from one cloud to another than moving data center and changing hardware suppliers. And the next implication to this is that we should think about moving systems and not moving data center when we adopt the cloud. I think next important point to think about is that cloud is a piece of software. This is quite a bizarre concept if you think about it, because for a lot of us, we think of cloud as infrastructure, and infrastructure constitutes hardware. But with the cloud is a piece of software. The cloud is delivered today through APIs and programmatic means. Be it you're using CloudFormation, as well as IAC or even Terraform, cloud is a piece of software code that represents what it is. And while we like to review our architectural diagrams, cloud has its benefits, because now we know how the system will be like. It is neither right nor wrong, but it's an accurate representation of code. And this also means that we can bring about new software engineering concept or old software engineering concept into cloud infrastructure. We can apply very humanistic approach like pair programming, peer review as part of our CI/CD pipeline for infrastructure. And we can also apply very automated techniques like static analysis and automation testing. And closely related to this is the notion of cloud as a service. And service is a much abused word in IT, as we all know. It means a bunch of different things. And for us, today I want to think about service as differentiated from goods, the physical object. And in the hardware world, we think quite a lot about appliances. Appliances serve a particular purpose, and they serve it well. And we can assemble all the appliances to form a larger system. But I think it's one thing to think about appliances this way. You can think about it in a particular way, right? From a layman perspective, we think about appliance like a dishwasher as an appliance. But when my daughter is washing dishes, either with her hands or with the dishwasher, that's called providing the family a service. And there's nothing about the how of doing it. It's more about the what. And I think this separates us away from the notion of physically knowing what the compute or the storage is all about, and not even the logical concept of it. And a very famous service is functions as a service. And many of us will know this as the AWS Lambdas of the world. They are able to abstract compute up to a single unit of execution, the function itself. And this function can be billed to you at a fixed charge rate. And there's no need for us to know about the hardware, physical infrastructure, and neither do we need to even know about the logical representation of compute. It just serves as a function. And I think next up, we also have new language that we start using with cloud. We use terms like spin up and spin down. And in the past, we used to have this word, the BOM, the bill of materials. And the bill of materials actually is an industry of its own. We have procurement specialists, we have all these sourcing specialists who source for us the best deals, the most speed for use appliances, and then we aggregate demand. And if there's one change all governments can take on using the cloud, is this use of cloud as a service. The infra as a service, the software as a service, the platform as a service. Because it's completely upended the whole procurement process, you can now just literally go to the cloud and use it. And it's also very important that today the cloud services is an a la carte service. You can decide and self-curate what you like and spin it up to the amount of resources required. And sometimes you can even specify the quality aspects of it. Whereas in the old world, right, we used to have larger contracts that are more curated, but not curated by us, but curated by our partners. And sometimes they tend to have, for whatever reasons, over-specification because of long-term capital investment. And unfortunately, this gets us locked in. And I think the technology fabric of cloud has also changed quite a bit. Because the cloud itself is out in the internet. And what this means is that our traditional perimeter and firewall defense, they only serve to protect a small part of it. And the cloud itself, sometimes we don't even think about the networks. We care a lot more about the endpoints, how secure we are with the endpoints, and what are the access that's required. And that's why we need to be what we call IAM focused, and this means focusing on identity and access management. And one important thing about cloud is about people, right? And this is the part where cloud has actually made it much easier for us to do a lot of things. And as engineers, this means that we have to take on more load. And rather than be specialists, we now look for people who are more equipped to understand both networks as well as services and modern architecture. And I think we should give ourselves a pat on the back in the government, right? We have actually mastered the art of using the cloud to some degree. We have simplified our procurement. We have moved from enterprise contract into service contract. And through this replatforming, we have actually done from all the databases now is delivered as a service to us, as opposed to enterprise products. And we have now shortened our time to market to set up infrastructure to be able to deliver. And we're able to precisely state the kind of resources we need to support our system. But there's still more to be done. I think today we still think of cloud as a piece of hardware. We still like to review our architecture diagrams. And I do like to review my architecture diagrams, but I think it's also very useful for us to code this architecture into code and basically deploy it. And if it's incorrect, let's just tear it down and redeploy again. We no longer need to be constrained by the art of planning in a waterfall manner, right? Where we think about architecture diagram, debate it for a few months before we deploy something. And it's also important that we think about cloud as a service. I think a lot of the migration that happens today, we are very concerned about the way we think about our security posture and such. We take whatever we have on the on-prem data center and we migrate them to the cloud. And sometimes we have to seek appliances that does not have a ready equivalent on the cloud. And I highly encourage, as we think more about this, we should adopt cloud more as a service rather than just migrating appliances over. And I think one thing I've mentioned quite a bit is that because the cloud is out in the internet itself, we need to be more IAM focused, the identity and access management way of thinking. And this will require us to rethink the way we write system policies, the way we think about system governance, down to the digital applications that you're going to develop. And this is a part where we will need to invest some time in the upcoming future. And the part about the generalists that I spoke about, I think this is a part where we need to retrain and reskill ourselves such that we can cover a breadth of knowledge rather than a specific skill set. And I think through this retraining as well as selective new hiring, right? Like the interns that Tom was talking about in the earlier keynote, we're able to build up this core capability within ourselves to deliver cloud services. And I think just want to recap this at a visual perspective, right? We are kind of in the middle of our journey. We have done well in terms of achieving savings, and we have done well in terms of reducing time to market. But if we can adopt a more software and service approach to adopting the cloud, we can evolve the way we think about security paradigms to IAM, and we can upskill our mindset as well as our skill set. We'll be able to reduce the cost even further. And cost is just the top or tip of the iceberg. I think we can definitely do much more to reap all the benefits of what cloud has to offer. And I gave you a theoretical version of what I think about the next agenda of the road ahead is. But it's also very important we stay grounded and get the feedback from the ground. And this is what we've heard about the ground, from the ground on GCC 1. We have heard definitely the onboarding process is very tedious, it's very long. And we hear that there's a lot of service requests, no use of automation. And while we hear some positive feedback, like GCC is 10 times better than the government private cloud, GPC, but we have to acknowledge that most of the feedback has been mixed. And the main idea is this, right? Cloud needs to operate like a cloud. It cannot operate like a data center. And we also learn a lot through our operations of the cloud itself. And this is a diagram that we use quite a lot to depict our cloud platform. At the bottom, we have the system policy as well as the data residency requirements. It states the requirements in terms of system policy of how workloads should be installed on the cloud. And we talk about, on the left side, the onboarding and billing, which is about users getting started, the engineers able to work on the cloud directly, and based on their usage and consumption to be able to accord the right bill to their agency. Then we have operating a cloud at the top, which is all about centralized monitoring and logging, as well as having a consistent jump host for us to administrate the cloud. And then on the right side of this platform, we talk about on-prem connectivity. This is how we have connectivity from on-premise system with cloud systems. And now a little bit about the learnings. And I'll start on on-prem connectivity and go anti-clockwise back. So on the on-prem connectivity, right, we have learned that actually government workloads are still pretty much what we call hybrid in nature. There is still a need for us to have connectivity back on-prem to retrieve some data and vice versa. And we'll continue to need to support this. And then on the monitoring and logging aspect, what we have learned is that when we first started this journey, the CSPs themselves are not as enterprise ready. But they have since then caught up quite a bit. And we must be always on the lookout for new advances from the CSPs that we can adopt the cloud better. And onboarding. Onboarding is the greatest pain that we have. We have like 4 accounts to be able to administrate the system. This is the cloud account that we have, the portal account that we need to have, the VPN account that you need to use, and the jump host account. And just be able to log in and administrate the system needs to go through this 4 steps. It is a pain, and we recognize that. And I think on the bottom right, from a policy perspective, we realize that we have set our policies a little bit too tight. And what happens is that when agencies, for whatever reasons, need, and for good reasons actually, they need to reduce the requirements of policy, we find very hard to loosen the requirements because it will affect all the workloads. And as a result, we keep the high line, and developers have to figure out workarounds to address the shortcoming of how constrained the policy might be. And so we have not stayed still for GCC. We have actually improved quite a bit because the CSP providers has now become more enterprise-like. We have started looking at some of this workload administration. We know that the jump host is a pain in a few ways. I think it's costly and it's not user-friendly. And I'll just take two examples, right? Microsoft Azure, they have this Bastion. The Bastion is a jump host that is a hardened jump host with all the security controls. And then on top of it, it has zero-day patching capability. And then for AWS System Manager, Session Manager, it takes a slightly different approach. It isolates the administrative control with their internal networks and agent, minimizing configuration. We know for a fact that it's definitely much better to use native services simply because it's managed by CSP, and it will be more cost-effective. And we also know in practice, from a security standpoint, it is also more secure because there's less configuration needed. And on our end, internally, we also like to secure our endpoint. And we have taken an approach to move our on-prem-like thinking to become more cloud-like. And in the afternoon, if you are attending the Cloud Platform and Tools track, you'll hear more about Seed, which is the security suite for engineering endpoint devices. And Seed basically is a way to have control of the endpoint and to be able to have convenience access to cloud resources without going through so many hoops of the VPN. So for those who are interested about Seed, please attend the session in the afternoon. And while we can make improvement to GCC 1, right, what we realized that we hit a roadblock, there's a limit to incremental improvement. If you want to be more cloud-like, we need to rethink about how we build and operate our cloud. And that's the conclusion we came to, right? We realized that the cloud platform itself is actually part of the cloud. We should be more software-like. We should think of it like a software platform and not a hardware platform. And we need to encourage and proliferate the use of cloud services and stop thinking about cloud as a set of representation of the data center. And because cloud is moving towards an IAM focus, we need to have a strong basis of IAM controls. And taking this all collectively, right, we realized that we need to build in-house engineering capabilities to engineering the cloud platform. And how this translates to the new GCC tool that you'll hear more about shortly. From a software perspective, we are now relying more on infrastructure as code. We implement our CI/CD pipeline to deploy the cloud platform itself. And we need to think about how we encourage more native use of cloud services. And we do this by having less static system-wide control. We have less system policies and have more dynamic configuration controls, which allows us to not always terminate all the access. We can sometimes just send notification if the configuration is not up to mark. And from an IAM-focused perspective, we will consolidate all the accounts to a single account, and so that we have strong account identity and we can associate roles and policies to all these accounts. And just very quickly, right, about the roadmap, which I know a lot of you is after this roadmap. So what we have today is that we have piloted some workloads on AWS. That has been going pretty smoothly, but like all piloting, there are things that we still have to resolve. And we plan to go to general availability sometime in the first quarter of next year for AWS. And following that, we'll do the Azure pilot. We aim to have that generally available sometime in the third quarter of next year. And then for GCP, we are still thinking about it. It's likely to hit the shelf, so to speak, in 2023. And then in terms of support, we also realized that even for GCC 1, it's useful that the L2 support is supported by ourselves. And that's why we're also moving the support from a vendor outsource model to an in-source model, where we then will be taking on more support activities sometime in the end of 2022, the last quarter. And we'll continue to make iterative enhancements to GCC2. And now because we own it like a software platform, we're able to enhance it as and when we need it. And we still look out for very strong co-source partners who are very capable to develop cloud platform and have developed niche areas. These are partners we are really interested to partner with as we continue this journey together. And I know for the public officers and some of our industry partners, the transition to GCC1 and GCC need to be thought through. We need to be very, very careful and thoughtful and mindful about how we continue supporting this GCC1. And we'll definitely work with you very closely to make sure that the workloads continue to stay up and you continue to advance on your use of the cloud. And finally, I just want to leave you all with this thought, right? That the Codex platform is a platform to hand over to the developers for them so that they can focus on solving the engineering problems. And we like them to apply the expertise. We like them to share their knowledge. We like them to learn from one another so that they can become engineers, better engineering teams. And this is how we as a community, right, regardless of public or private, we as a community upskill ourselves. We can all learn together And this is how we structure the next road ahead, right, for this new dynamic workforce that knows how to address the cloud. And with that, I'd like to thank you again, and I look forward to seeing you in some of the later sessions. Thank you very much.